Welcome back! In the second instructional video of the first module, we'll review some of the methods we use to estimate the age at death of adult skeletons. First, though, let's pick up with a discussion question raised at the end of the last video. We asked you to think about what factors could cause a discrepancy between an individual's chronological age and the age shown by their bones and teeth. Well, this potential problem becomes even more pronounced for adults. This largely has to do with the fact that growth in subadults is more controlled and occurs over a shorter time span than the breakdown and degeneration of the skeleton that we have to assess in adults. So, as you'll see, many of our adult age at death methods yield estimates with large ranges. They are fairly imprecise. This is to accommodate the large inaccuracy that we encounter. Factors such as activity and occupation, diet, disease, sex and hormones, and ethnicity all influence the rate at which a person's skeleton breaks down. And these may be rather far removed from that person's calendar age. After around 50 years of age, degeneration patterns become too unclear to put individuals into smaller age groups. It's for this reason that we have a limited number of age categories to classify adult age, such as these. The three main categories are young adult from 18 to 34 years, middle adult from 35 to 49, and old adult, which is 50 plus. Because there are a few late fusing epiphyses, such as the inner medial collarbone called the clavicle, which doesn't fuse until around the age of 25 years, we can often divide the young adult age category into two subgroups or subcategories. Early young adult from 18 to 25 years and late young adult from 26 to 34. In the rest of this video, we'll go over three common methods that are used to estimate adult age at death. Note, these are what we call macroscopic methods, meaning they're things that you can assess with the naked eye. We will not be reviewing microscopic methods, which are methods that require a microscope and are based on the proportion of different types of bone cells that increase or decrease with age. The three macroscopic methods are ectocranial suture obliteration, pubic symphysis morphology, and auricular surface morphology. It's a lot of big words, but don't worry, it will be clear soon. So, for the first method, we use the cranium, specifically the cranial sutures. As you get older, the suture lines, seen here as a bit open and distinct, begin to close, and the suture line starts to be obliterated or lost. The method we will show you today is based on the age of suture obliteration on the exterior side of the skull, called the ectocranial surface. By old adulthood, the cranial vault may look like it consists of one single bone, while in fact we know it is composed of many. The most common method used today was developed by Mendel and Lovejoy. Briefly, they developed a method that scored 10 separate suture areas on a scale from 0 to 3. 0 equals no cranial suture closure, 1 equals minimal closure, 2 equals significant closure, more than 50% of the area, and finally 3 equals complete suture closure, where the suture line is completely obliterated. Within one cranium, some sutures may exist at closure levels of 0 or 1, and others can exist at closure levels of 2 or 3, and this is normal. So one then adds up the scores given to the suture areas and compares that cumulative score to the tables provided by Mendel and Lovejoy. One of the tables is shown here, and you can see how if you had a cumulative score of 9 for the 7 suture areas on the cranial vault, this would put you into this row and give you a mean age estimate of 39.4 years with a standard deviation of 9.1 years. You can think of the standard deviation as a plus-minus factor, So to give an age estimate of about 30 to 48 years, basically meaning the individual was likely a middle adult. However, you might also notice some additional data, which are important in assessing the accuracy and precision of the method. Look at the sample size this method is based upon. Also, note that the full age range of individuals with scores 7 to 11 was 24 to 60 years. Thus, in their method, a fair number of non-middle adults wound up being classified as middle adults. And one can reasonably assume the same might also be true for a sample of adults from an archaeological site. So it's no wonder that osteoarchaeologists have looked for other methods to supplement the age given by cranial suture closure. It's a good start, but hopefully not the only clue we have. The next adult age estimation technique uses the shape or morphology of the pubic symphysis. This is where the two pubic bones meet at the front of the body and are joined through cartilage, and they undergo relatively regular changes in morphology from adolescence onwards. Basically, in adolescents and early young adults, the surface is undulated and rugged, showing a series of ridges and grooves with no rim around the outside of the surface, as seen here. With increasing age, the surface becomes flatter and develops a rim, as seen here. And finally, by old adulthood, the pubic symphysis is completely flat, even slightly indented, often with a porous or a pitted appearance and spicules of bone along the margins. Pubic symphysis morphology is the most common method of adult age estimation, with many different methods having been developed. The Suchi-Brooks system is the most widely used method today. It's a 6-phase system based largely on a sample of autopsy room males and females for whom legal documentation of age was provided by death certificates. This sample is comprised of individuals of many ethnicities born in the United States and Mexico. Separate standards exist for males and females, and the authors created plaster casts to depict the different stages, seen here. Suchi-Brooks had the user assess 5 different areas of the pubic symphyseal face, shown here: the ventral or front border, dorsal or back border, superior extremity, inferior extremity, and the pubic face. And they had the user observe variables such as the formation and then subsequent deterioration of different parts of the rim and the presence of ridges and furrows. This is then followed by the flattening and erosion of the face, with bony nodules also occurring. To see this method in action, there is an optional video under course documents where Christine will demonstrate how to score the different areas of a pubic symphysis and use that to derive an age estimate. So, based upon the stage that you think best describes the appearance of the pubic symphysis that you are analyzing, you can then use this chart to get a mean age, the standard deviation, and the 95% confidence interval. Again, note that some of the ranges are quite large. There is another area of the pelvis, this time towards the back, where your tailbone or sacrum articulates with the pelvis. This area is called the auricular surface and can be used for adult age at death estimation. This area is more often preserved than the fragile pubic face. The technique is similar to that of the pubic symphysis. We observe different areas and features of the auricular surface, which results in a score that provides the estimated age. Lovejoy and colleagues were the first to develop an auricular surface method, and you can see photographs of the different age stages here. There have been adjustments to the method since, and in our lab we used the method of Buckberry and Chamberlain. They score the appearance of 5 features of the auricular surface. These are transverse organization, surface texture, microporosity, macroporosity, and changes in the morphology of the apex area. One adds up the scores of each separate area to get a composite score and uses this table to derive an age estimate. No difference has been found between males and females, so only one table is needed. To see how this works in more detail, and to find out what terms like transverse organization and microporosity actually mean, Anna Marine will show you how to estimate the age of an individual using the Buck-Berry-Chamberlain method, and this is in another optional video you can find under course documents. In this video, you learned about 3 common methods that human osteoarchaeologists use to estimate the age at death of adults. Note there are several other methods not covered in this video. You've seen why we have to use quite broad age categories. It is important to note that whenever possible, one should apply as many aging methods as possible to try and improve the accuracy and precision of your estimate. Put the most reliance on the method or methods with the best proven accuracy. And as always, use standards that match the geographical origin and life ways of the population you are studying as closely as possible. Do so to limit the potential difference between one's physiological age and chronological age. Now, you've probably noticed that some of the age estimations contain tables for males and females separately, while other methods make no such distinction. On the online forum, you'll find a question asking why this might be. Why might some areas of the body age differently in men and women and others not? And this question leads us nicely into the topic of the next video, which is sex estimation. See you there.